So now we are into hypothesis testing. So the first thing to do on this one, test the claim that the overall, well, whenever you're given a list of data, and we're going to be working with raw data like this quite a bit from now until the end of the semester, is we need to enter that in the lists. So when we do these on this video, I'm not going to sit here and videotape myself typing all of the numbers in. I'm going to do that ahead of time. So I've got the numbers in list 1 and list 2, homework and overall. Okay, and then on to the actual problem. So test the claim that the mean for overall. So the first thing I need to do is find out what's the mean and standard deviation for the overall. So keep in mind that when I entered them, the overall was in list 2. So you need to calculate the one variable statistics for list 2. So you go second, the number 2, and it gives you list 2. And there we go. The mean is 74.576. So we've got a sample size of 33, a mean of 74.576, and a standard deviation 12.708. And then the next thing to do is work on the claim. So the claim is that the mean, so that would be mu, is over 70. So H1, since this is a greater than, then H1 also has greater than. And then that's the one that tells you if it's left-tailed, right-tailed, or two-tailed. When it points to the right, it's right-tailed test. And then H sub O is always equals no matter what. Okay, so then we would have a normal distribution. And then it's a right-tailed test. So you take the alpha, which is 1 minus this, so 1% or 0.01. And then that would go in the right tail, 0.01. And then we need to look up the critical value. Well, since this is only the S standard deviation, then we're going to be using the T distribution for this problem. So we've got the table A3, or the T distribution, and we need to find out what the critical value is. Well, we use this part because it only has one tail, and for that one tail, it's 0.01. The next thing we need to know is degrees of freedom, which is the sample size minus 1. So that means the degrees of freedom is going to be at 32, and write that down. Okay, so we use this column that has the 0.01, and degrees of freedom of 32 is down here. So you go down to 32, and it's 2.449. 2.449. So the idea of a critical value is that is the line in the sand. If we calculate the test statistic and it goes past that line in the sand, then yes, we did actually prove something. So let's see. The test statistic, you can use the calculator to find. So you go over to tests, stat, go over to tests, and this is a t-test. We would only use z if that right there were sigma, the standard deviation for the whole population. So with the t-test, you can either type in this data yourself, or you can have the calculator do it. So if you want the calculator to do it, put this on data, hit enter, and then the mean in the claim is 70, and then the data is in list 3. Excuse me, it's in list 2. So I just have to put second 2, And then this part is trying to determine the tail, so that comes from H1, pointing to the right, and then calculate. So the test statistic is 2.068. So T is a 2.068, which does not go past a 2.4. So in fact, it lands in here somewhere. And that means that we do not have enough data to prove anything. It means that, yes, it is slightly above 70, but having only 33 people, that's not enough evidence to really prove anything. So then formally what we say is fail to reject, or in other words, we were not able to prove anything. Fail to reject H sub O. And then the next part, you can say there's insufficient evidence, or we cannot prove anything. Oops. And then you can go on to say due to a lack of data or something like that. But that's what this one is. If we just had more data, we would be able to prove it. Let me just experiment real quick. If I went back to the tests and go to the t-test, and I tell it, okay, change this to 63 people instead of 33. Leave everything else the same, but just change that to 63 people. Then the test statistic would turn out to be a 2.8, which then does go past this. So it's 63 people. Then that would be enough evidence to prove it. With 33, not enough evidence. Next is another hypothesis test. The key word in this one is majority. Majority means that the percentage is over 50%. So it's implying a simple majority. So that's a claim about proportions. So for proportions, you need to know, well, what's the sample size? And then count how many are doing whatever this is talking about. So then for passing the class, then it's just a matter of out of the 33 people, you just count how many are passing the class. So passing means 70 or over, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then I would usually go and double check, but of course I worked out the answers before starting to record here, so I've already double checked. In fact, that right there was a triple check. So it's 24 that are passing. So 33 people, 24 are passing the class. And then you could even find out, well, what sample percentage is that? So 24 out of 33 is 0.727. Okay, then we go on to the claim. The claim is the majority, so claim is that the percentage is over 50%. H1 happens to be pointed in the right direction, so right-tailed. And then H sub O, no matter what, has equals. And then we've got a normal distribution. This time it's same as last time, it's a 99%, so that means this is 0.01. So with this one up here, we did the t-test, for that one up there was the t-test, so that was table A3. Well, anything having to do with proportions, like this one is always a z. That means that it's A2. So the critical value is going to be a z value. And then what we've got to do is use the table A2, and because the z is on the right side, use the positive z-scores. And then look through here for whatever's closest. Let me back up a second. If this is 0.01 or 1%, then this is 99%. So this is where we're using the table backwards to find the z-score. So you look through here for whatever's closest to 0.99. Getting close, 99. There it is. So these are the two that are closest, but in fact this one is the closest. So that means the z value is 2.33. So 2.33. And then for the test statistic, it's going to be a z. And we would have stat, go over to test, and we're looking for one proportion. There's the one proportion. And then test. So this needs to be the number in the claim, 0.50. And then, as you can see, I just used this calculator for this problem. 24 out of 33 is it. And this is pointing to the right. So then calculate. The test statistic is a 2.611. 2.611. Does that make it past 2.3? Yes, it does. Which means that we actually did prove something. But we begin by saying reject H sub O. So the H sub O said it equals 50%. And this is saying no, it doesn't. In fact, it goes to the right, so it's over 50%. So this, sure enough, that's way over 50%. Okay, reject H sub O. So it's not equal to 50%. Then the last thing to do is go back to the claim. The claim said it was going to be over 50%. Is that true? Well, since it's going to the right, that means over. You could also look at this and see, is that over 50%? Yes. So the claim is true. So you may say, well, in the last one, 33 people wasn't enough to prove anything, but in this one it is. Well, the difference is in here, this is 74 for the data. The claim had a 70, so that's only a 4-point difference, which a 4.5-point difference can be significant if you had 63 people instead of 33 people. Over here, 33 people is enough to prove it because the difference between 50% and almost 73% is huge. So you don't need as many people in order to prove that the claim is true. So the next part is now test that the two are equal. So you may remember I've got the scores in list 1 and list 2. So I need to find out the mean and standard deviation for list 1, which is the homework scores. So also write down the data. N equals 33 and the mean is 72.758. The standard deviation 14.977. And then for the overall, well, I actually have that at the top of the page, so I'm just going to use that. Well, that's fast enough to do it on the calculator if you go like this. So there it is for the overall, it's 33. Mr. Calculator, I need a little space. And then the mean is 74.576, standard deviation 12.514. And then the claim says that the two are equal. So what I can do is just call one of them group number 1 and the other one group number 2. And then the claim is that the mean for group number 1 equals the mean for group number 2. H1, the alternate hypothesis, cannot have equals in it, so that's going to be not equals. And then H sub O always has equals no matter what. Okay, then here's the normal distribution. Because of this not pointing to the left or the right, that means it's two-tailed test. So we've got a tail and a tail. It turns out that alpha is equal to 10% since we're going to be using 90% level of confidence. So for the two tails, it has to add up to 10%, which means that it's 5% and 5%. And then find the critical values. So this is going to be a t-test. Once again, because we only know the S standard deviation. So we would go to, well, I guess I can find the critical values first before doing that. So we go to table A3. The degrees of freedom, when you have two of them, the degrees of freedom is the smaller one. So degrees of freedom for each of them is 32, so we're going to use that, it's 32. And then table A3. So you can look at it this way. If you were to look at one of the tails, it has 0.05. Or if you look at the two tails in total, that's 0.10. Either way, it takes you to this column. And then go to 32, and it's a 1.694. So 1.694 and negative 1.694. And now for the test statistic. So go to stat, and then tests, and then to sample t-test. So you can either type the mean and standard deviation, or you can go to data and tell it to use list 1 and list 2. And then this means if you were to look at the list, every time a number was typed, how many times did you mean to type it? Or what's the frequency for each one? So just leave that at 1 and 1. And then this should be the not equals, which we found in the alternate hypothesis right here. And then pooled, always say no. The pooled means, are the two standard deviations close enough to each other that we could just pool them together? No. So calculate a negative 0.532. Negative 0.532. That would land somewhere in here. And since it's not in either of the tail regions or critical regions, we get failed to reject. We didn't prove anything. And the reason for this one is mostly there is not a huge difference between a 74.5 and a 72.3. So that means that the average homework is very close to the overall scores. There's not a lot of difference. And then we're on to page 2. And that is actually the next question. Test that the mean difference is equal to 0. So we have the list 1 and list 2 are the data, and the question is about the difference. So you could, by hand, subtract them. 95 minus 93 is 2. And 64 minus 71 is negative 7. And do that all yourself, or you can go like this. So you go, let me clear the screen. So what you do is say list 1, so second one, minus list 2, so subtract them. And then right here is store, so store that in list 3. And then when you go back to list 3, there they are. There's the differences. Well, the next thing to do in this is find out what's the average. So what's the average difference for list 3? So we've got a sample size of 33. The difference is called D bar, negative 1.818. And then the standard deviation of the differences, called S sub D, is 7.888. And then the claim that I asked you to test is that the differences is equal to 0. So the claim is that the mean for the differences is equal to 0, which would mean H1 can't have equals, so it's not equal to 0. That means it's two-tailed test, and then HO is equal to 0. Okay, then it's a two-tailed test. Since I didn't say what to use for the level of confidence, then use 95% for the level of confidence. That's always a fallback from this point on in the semester. Hopefully you already knew that. But yeah, when it's not mentioned, then use 95%. So that means alpha is 5%, which means that each tail is going to be 0.025. And then whenever it's a claim about a mean, there's either there's either the t distribution or z. But we end up using, because this is just the sample standard deviation, we end up using the t. And then this is simply the regular t-test, one of the very first ones we did with hypothesis testing. So the t-test, and then the number in the claim is 0. And I wanted to, yeah, I guess I don't need to type the information myself. I can just tell it, use list 3, that's where the differences are. And then this is H1, and calculate. So it turns out the test statistic is 1.324. So t is equal to 1.324, but I need to find out the critical values. So we've got 0.05, cut it in half. We're going to need to use table A3, the t's, and degrees of freedom is 32. So 1 minus the sample size. So with this one, you could say, well, looking at one tail, it's 0.025, or looking at the two tails total, it's 0.05. Either way, you use the middle column. And then degrees of freedom is 32. So a 2.037. Critical value is 2.037. Negative 2.037. And so this would land again somewhere in the middle, meaning that we didn't prove anything. So fail to reject H sub O. We did not prove anything. So there's not a big enough difference to prove that there is a difference. Okay, on to number 5. This first part is going to be a little bit challenging, but not bad. So the first thing to do is get a highlighter and highlight those people that have a passing on homework. So what you do is, passing means 70 or better, so you would look at their homework score and then you highlight that person. No, 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 yes. So you highlight all of the people that over here, their homework score is 70 or better. When you're done, it would look like this. So highlight all of them whose homework is 70 or better. Okay, now we're going to use this to answer the questions. So test the claim that the proportion of people that are with passing overall scores. So what we've done is something rather common, and that is you use one category to divide the people into two groups. The yellow people, the highlighted people. The highlighted people are doing well on homework. Now the question is, how are they doing overall? And then compare them with the non-highlighted people. So if you count the highlighted people, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 of them. So we've got the people whose homework is bigger than or equal to 70. There's 21 of them. So one small way to check your highlighting skills is, remember there's 33 people left, 33 people total. So for the people whose homework is less than stellar, that should be 12 people, because there's a total of 33 people. So then count how many non-highlighted people there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that's good news. Now the question is about proportion, which means you have to then go and count how many people out of each group have this. They're passing the overall. So then, just looking at the highlighted people, so these 21 people, how many are passing the overall? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wow, so there's only one person, namely that one, that isn't passing. So x equals 20 are passing. Okay, now look at the non-highlighted people and then count how many of them are passing. So 70 or better. So 1, 2, 3, 4. Wow, only 4 of them. So then x equals 4 of them are passing. So for each one you can find the proportion. This would be 20 out of 21. This would be 4 out of 12. I know that that's a third, so that's going to be 33%. I don't know the other one. 20 divided by 21. Okay, now I know the other one. 95.2. Wow, look at that difference. If you do your homework, the chances of passing the class, 95%. If you don't do your homework, the chances of passing your class, 33%. That's a not so subtle message. Okay, so then test the claim that the proportion is the same for the two groups. So it's going to be a claim, and then I could just call this group number 1 and this group number 2. The claim is that the proportion of group number 1 equals the proportion for group number 2. H1 can't have equals, so you make it a not equals, which means 2 tails. And H sub O would have equals. And then here is the Z distribution. since it's proportion, it has to be table A2, and it's 2 tails. And like the last one, I didn't say what to use for alpha, so use 0.05. That means that it needs to be cut in half. All right. And after a while, you would look at that and say, oh, the critical value is 1.96. But if you don't see that, then what you could do is, so it's actually easier to find this one. So find the negative z-score. So go to table A2 with the negative z-scores, and then look through the middle of it until you find whatever's closest to 0.025. There it is. And then you work backwards and say, well, that's negative 1.96. So 1.96, and this side would be negative 1.96. They're symmetric, since the graph is symmetric. And then for the test statistic, it has to be a z. And it's going to look like, let's see, we've got 2 proportions, and it has to be a z-test. Okay, for the first one, it was 20 out of 21 people. For the second one, it was 4 out of 12 people. H1 had not equals. And then calculate the test statistic, 3.841. 3.841. And then does that make it past 1.96? Yep, by a lot. It's out of there. Home run. Which means that we did prove something. So reject H sub O. And that means that the 2 groups are not equal, which we definitely saw back here. And so reject H sub O. The claim is false. Because the claim said that they were going to be equal, and you can see they're not even close. All right, for the next thing, now we've still got the people divided into 2 groups. So these directions up here apply to both A and B. So we have them divided into 2 groups, the highlighted and the non-highlighted. The next question is about their overall scores again. So what you got to do is take the highlighted people and put them in a list. So here's the people that are doing well on homework, and we're going to take their overall scores and then put them in a list. And then for the people that aren't doing well on homework, they're over here in list 5. Their overall scores are here in list 5. And then test the claim that the mean, so we need to go ahead and find the mean and standard deviation for those 2 lists. So stat, 1 variable stats for list 4. So this is for if their homework is decent, there's 21 people that do that, then their average overall score is 81.857, and the standard deviation is 7.268. That was for list 4, right? Okay, good. Just double checking. All right, now do the same thing for list 5. So these are for the people whose homework is below 70. And then there were 12 of them, and their average is a 61.833. And their standard deviation is 9.769. So is there a difference between the 2 groups? Yeah, by about 2 letter grades. A B compared to a D. Hopefully this is enough information to prove it though. So again, you can just call someone group number 1 and the other one group number 2. And then the claim is that the mean for one group is the same as the mean for the other group. So you've got, again, a two-tailed test. And again, the alpha is not mentioned, so use 0.05, or in other words, a 95% level of confidence. It's two tails, so 0.025 and 0.025. And because we only have S for the standard deviation, we're going to be using the t distribution, so that's A3. And when you have a choice of 2 degrees of freedom, then use the smaller one. So that's going to be 11. And then we just need table A3. So again, it's the area in the two tails together is 0.05, and degrees of freedom of 11 is just right here. So we're looking at a 2.201. Critical value is 2.201. And then the last part is the test statistic. So it's going to be the 2-sample t-test, and I don't feel like typing the data in, so I'll tell it it's list 4 and list 5. And then, as I remember, this one was not equals right there. And pooled, no, always. Calculate the test statistic, which is t is equal to 6.189, which again is way out of there. And so definitely reject. Definitely we proved there is a difference. So reject H sub O. The claim is false. Are the two groups equal? No. As we saw over here, there's about 2 letter grade difference between them. So anyway, then the last one I've actually been doing all along. So explain what it says. Well, you can see there's a huge difference in the average grade. What's the chances of passing if you do your homework versus if you don't do your homework? There's a huge difference. Is there a big difference between homework and overall? No. Which in a way, that's what this and this one are saying. If you do well on homework, you're most likely going to do well in the class. If you do well in homework, you're most likely going to do well in the class. And then this is saying, is there a big difference between the two? No, there's not.